and Tashi direct to all the class 12 students. And today I will be continuing with the last topic of local maxima and minima. Okay, and in the last class you had seen how using the derivative we can find out the point of local maxima and minima. Okay, so for that we had taken two methods, that is first derivative test and second derivative test. So using any of these two methods you can be able to find out the point of local maxima and point of local minima, corresponding to which you will get the local maxima and local minimum value of the functions, right? Okay, and also we had defined the maximum and minimum values of the function. Okay, next today we are going to deal with the same concept of local maxima and minima, but the way the question is given is slightly different. Okay, so you were doing this chapter, that is application of derivatives, and we were discussing the topic local maxima and minima, local minima, right? Okay, and before defining the local maxima and local minima, we had defined what is the maximum and minimum values of the function. So if I quickly just recall what we had did in the last class, so we had seen that for a function the maximum and minimum values, okay, may exist, it may not exist. If it exists, then the maximum and minimum value, or you can say that extreme values, is unique, right? But it is not that every function will have a maximum and minimum values of the function. It can it may have, it may not, right? So if it does, then the maximum or the minimum value is unique for the function in that given interval. So that is one thing we had observed, right? And whereas when you are finding out the local maxima and local minima value of the function, then what you had seen is for a function you may have more than one local maximum or local minimum value of the function, right? Because we are in the given interval, we are dividing that into different sub intervals in which we are finding out the local maximum value and local minimum value. So for a function in a given interval, you may get more than one local maxima or minimum value of the function. Okay, so these were all the things we had discussed in the last class. Okay, so today we are going to take one topic, that is optimization problem. Okay, so in here also we are going to apply the concept of local maxima and minima, for which you have to apply derivative. So it is one of the application of derivative. Okay, and before that, before optimization problem, I want to define, or I want to discuss a small topic that is absolute maximum and minimum value of the function. So this is very basic concept, right? So when you are given this maximum and minimum value of the function, then you know, right, in the whole interval you have to find out what will be the maximum and what will be the minimum value of the function. And when you are just given find the minimum and maximum value of the function in an interval, then the interval may be open interval, it can be closed interval, it may be close open, it may be open close. So any of the interval it may be given, right, when you are asked to find out the maximum and minimum value of the function. But whereas when I ask you to find out the absolute maximum and absolute minimum value of the function, then the given interval will be always closed interval, right? So you will be asked to find out the maximum and minimum value of the function fx in the interval ab, closed interval ab, right? So when we had discussed maximum and minimum value of the function, the first topic, okay, so then we had seen that when the given interval is closed interval, then you will always get the maximum and minimum value of the function, right? So therefore, when you are asked to find out the absolute maximum and absolute minimum value of the function, then you are asked to find out the maximum and minimum value of the function, whereas the given interval is always closed interval. So in this case you will always get the maximum and minimum value of the function, since the given interval is closed interval, right? So we will take one example. If I give you this, say find the absolute maximum and absolute minimum for the function fx is equals to x squared plus x plus 1 in the interval, see if I give you, or if I write, okay, minus in the interval 1, 5, okay. Now you can see if I give you this, okay, negative 1 to 5, right? So now it is somewhat like this, okay. Our interval is from negative 1 to 5, okay. Now it is closed interval, so therefore these 2 points, right, image of these 2 points are to be included, okay. So because x can be negative 1 and x can be positive 5, so therefore we have this closed interval whenever you are asked to find out the absolute maximum and absolute minimum, okay. Now what we are going to do is, now in this interval, okay, the graph of the function, okay, either it will be increasing, strictly increasing function, right, or it is strictly decreasing, or it is neither increasing nor decreasing. So these are the possibilities of the function, of the nature of the function in the given interval. Either in that interval the function will be strictly increasing, or it is just increasing, or in this interval the function may be strictly decreasing, or it is just decreasing, or it is neither increasing nor decreasing. So these are the 5 possibilities, right, of the nature of this function in this interval, okay. So therefore if the function is increasing or strictly increasing, then the graph will be somewhat like this, is it? So therefore the maximum and minimum value of the function will lie at the extreme points. That is very clear, right? When the function is in this interval, when the function is strictly increasing or just increasing, then the maximum and minimum value of the function will lie at the 2 extreme points, okay. So since negative 1 and positive 5 are to be included, therefore negative 1 in this case, therefore negative 1 is the point of minimum value of the function, and 5 is the point of maximum value of the function, okay. So therefore f of negative 1 is minimum value of the function, and f of 5 is the maximum value of the function. That is one possibility, okay. Second case is, okay, second case is the function may be decreasing in this interval, is it? Again, when the function is decreasing, okay, then what happens is the extreme values, the maximum and minimum value of the function lies at the 2 extreme points, right, okay. But what happens when the function is neither increasing nor decreasing, okay? So now that's also one possibility, right, that can also happen, okay. So if in the interval negative 1 to 5, if the function is somewhat like this, okay, okay, say you are giving this, okay, then you can see what we can see is, if the function is neither increasing nor decreasing, okay, then the function will have at least one critical point, because the function has to change its behavior somewhere, because it is neither increasing nor decreasing. Neither increasing nor decreasing means increasing and decreasing both should happen in that interval. So when a function is increasing and then when it starts decreasing, that point at which the function is changing its behavior is called as the critical point, right? So at least one critical point will be there for this function in the interval, okay. So now you can see, when you are finding out the absolute maximum and absolute minimum, okay, so then what possibilities we have when the function is neither increasing nor decreasing. So when you look at this function, if the graph of this function is, suppose it is like this, I'm just supposing it, right, suppose it is like this, then you can see at negative 1 the function is attaining its minimum value, okay, and at this point, okay, let it be C, okay, at this point the function is attaining its maximum value, is it, right? So therefore you can see either when you are finding out the absolute maximum and absolute minimum, okay, so then either the absolute maximum and absolute minimum values will lie at the 2 extreme point or at the critical points, okay. So that is the only possibility. When you are finding out the absolute maximum and absolute minimum value for a neither increasing nor decreasing function, then the only possibility we have is the absolute maximum and absolute minimum value of the function will either lie at the two extreme points or at one of the critical points, right? So for example, when you consider this function, then minimum value lies at -1 and maximum value it lies at c. So it's clear, right? Now you can take another type of the graph of the function. If I consider, say, if my graph is like this, okay, in the interval a to b, okay, so now you can see the function is attaining its minimum value at a and maximum value at b, okay, and since you are finding out the absolute maximum and absolute minimum, the these 2 points are to be included because we have to take the closed interval. So therefore the minimum value is f of a and maximum is f of b. So this is one possibility, okay. Also you can have the graph somewhat like this. Say it is in a b, okay. If I consider okay, now you can see at this point, let it be c1. At this point the function is attaining its minimum value at c1, and at c2 the function is attaining its maximum value, and you can see c1 and c2 are the critical points, right? So these are different types of the graph of the function of neither increasing nor decreasing function, and about the absolute maximum and absolute minimum. So for a neither increasing and nor decreasing function, the absolute maximum and absolute minimum values will always lie either at the critical points or at the two extreme points, okay. So therefore it is very easy for us to find out the absolute maximum and absolute minimum. First of all, you will see if you get certain critical points or not, okay. If you are not getting any critical point, right, so then it means the function is either increasing or decreasing. If a function keeps on increasing, then it is no way changing its behavior, so then you will not get any critical point. Similarly, when a function is when a function keeps on decreasing, it's a decreasing function, then the function is no way changing its behavior, so again you will not get a critical point, okay. So therefore when you are finding out the critical point and you are not getting any critical point for that function, then it means the function is either increasing or decreasing. Therefore you are not getting any critical points, right? If a function is neither increasing nor decreasing, then you will get at least one critical point, right? Okay, now we will check this. So first you will find out f dash x, because by equating f dash x with 0, we get the critical points, okay? So this is 2x, okay, minus 1. So this is f dash x. So for critical point, you will equate f dash x is equals to 0. So you get 2x minus 1 is equals to 0. So x is equals to half. So we get one critical point over here for this function. So it means the function is neither increasing nor decreasing. Okay, so the function is neither increasing nor decreasing. Now you have to find out, okay, the absolute maximum and absolute minimum. So therefore, now it is not possible that you can substitute each of the real numbers in this interval and see which is the maximum value and which is the minimum value. That you cannot do. It's not possible, okay. So therefore, what you will do is you will find the function values at the two critical points, two extreme points, okay, f of -1, f of 5, and then you will find the function value at the critical point, whatever critical value you get, okay. If you are not getting any critical point, then it is simple. The function is either increasing or decreasing, and I had shown you that when the function is increasing or decreasing, then the maximum and minimum value lies at the extreme point. So you will just find out these two values and see whichever is greater, that is the maximum value of the function, and whichever is smaller, that is the smaller value of the function, minimum value of the function, okay. But since we are getting one critical point here, so therefore you need to check the function value at all these points, and the maximum value, that is the maximum value of the function, and which is the smallest one, that is the minimum value of the function, okay. So f of -1, now you remember here we are finding out here the function value, so therefore you have to substitute -1 here in this function. Okay, what I notice is many a times the student, they find the function value and substitute it here, which is totally incorrect. This is the derivative, not the function. Since you're finding the function value, you have to substitute -1 in the function. Okay, so here this is -1 square minus -1 plus 1, so that is 1 plus 1 plus 1, that is equals to 3, is it? Okay, then you will find out 5, that is 5 square minus 5 plus 1, so which is 25. 25 minus 5 is 20. 20 plus 1 is 21. Okay, and then you will have to find out half square minus half, okay, plus 1, so half, okay, this is 1 by 4 plus 1, so that is 1 minus 1 by 4, so that is 3 by 4, is it? Okay, so these are the three values we got. Okay, so now you look here, which is the maximum value? 21. Okay, so 21 is the absolute maximum value of this function, right? And 5 is the point of maximum value of the function, because at this point 5, the function is attaining its maximum value. Okay, and which is the minimum value? Okay, 3 by 4, it is the minimum value. Okay, and half is the point of minimum value of the function, because at half the function is attaining its minimum value. Okay, so always remember, when you're asked to find out the absolute maximum and absolute minimum value of the function, then the given interval will be always closed interval. So therefore, first, to find out the maximum and minimum value of the function, you have to find out the derivative, okay, to get the critical points. So if you get at least one critical point, so then you will find out the function values at the two extreme points plus all the function values at the critical points you had obtained. Okay, so out of all these values, the largest value, okay, that is the maximum value of the function, and the smallest is the minimum value of the function. So this is all about absolute maximum and absolute minimum, right? Okay, so this is just a generalization of the maximum and minimum value of the function. Okay, and I thought it is important to discuss, otherwise I think many of you will understand this, right? Even if I don't discuss this over here, because it is same with the maximum and minimum value of the function, right? Okay, now we will discuss the next topic, that is optimization problem.